Welcome to Talking Data Equity for Friday, August 9th. And my name is Heather Kraus. I'm a mathematical statistician, and I'm the founder of an organization called We All Count. And the purpose of We All Count is to help build tools and training and provide support that helps anybody that's working on a data project align the choices that they're making in that data project with the values and the equity goals of that data project. And one of my favorite things to do every week is to host this event called Talking Data Equity, which you have your major way to. And I'm very, very happy you all are here today because we have a fantastic event for you today. If this is your first time here at Talking Data Equity, welcome. And to all you regulars, it fills my heart with joy every time I see you pop into to the event. And you can see that we run this as a Zoom meeting, which means that you have control over your own video and your own microphone. And what we're asking you to do is to keep your microphone off for the first part of our session today, where we're going to have a special guest share some stories and some experiences. And then we'll have time at the end for discussion and live Q&A. And at that point, feel free to turn your microphone on and ask questions and have a conversation. And if you want to ask questions and have a conversation in the first part, feel free to do that using the Zoom chat. And we have the Zoom chat set up so that you can have a conversation with everybody if you use the drop-down menu set to everyone. Or if you just want to ask a question to me or make a comment privately to me, you can always just put my name, which is Heather Kraus, in that little blue drop-down menu, and I'll amplify your question to the extent that I can. Usually there's more questions than I can amplify, but you don't have to attach your name to it. Okay, so you can tell that I'm a little bit rushing through the logistics today, and that is because I'm over the moon excited to tell you about our special guest. Our special guest today is somebody who has written a book that I absolutely adore. So I'd like to introduce to you, or reintroduce to you if you already know her and her work, Dr. Constance Hilliard. And Dr. Hilliard is a professor of evolutionary history at the University of North Texas. She's best known for her pioneering research in the field, which lies at the intersection of environmental health and genomics. Dr. Hilliard received her PhD from Harvard University in historiography, and she's the author of a really fantastic book. If you haven't already read it, highly recommend you get it. The name is Ancestral Genomics, African American Health in the Age of Precision Medicine, published this year by Harvard University Press. And if you didn't get the exact resource to the book, one of the things that we do is I will put the recording as well as a whole bunch of resources and links to the things we talk about here. I put that in our forum. So you can always afterwards go over to the forum and get all the resources if you don't have time to write it down now. Okay, so enough from me. I am so excited. Dr. Hilliard does not have a lot of time, does not do a lot of presentations, and we are really, really fortunate that she has made time to spend some of it with us today. Thank you so much, Dr. Hilliard. Let me turn it over to you.
Okay, Heather, thank you for this very warm introduction. I'm so excited to be a part of your Talking Equity today and to have an opportunity to interact with your audience. We're going to be discussing when data equity suffocates the story. And I have a particular case, the case of APOL1 mediated kidney disease. Now, before I get started, I'm going to try to share my screen, and I hope, oh, okay. Okay, wait. I apologize. I should have figured out how to put all this together before. Okay, wait. This meeting is being recorded. Okay, slideshow. Yes. And I apologize for all of that. Oh, okay. So here we go. My actual goal today is to introduce you to what I would consider to be a cautionary tale, and it's about power and blindness. Data in and of itself, whether it's accurate or not, can oftentimes wield enormous power. And this is quite simply because it is the language of the powerful and highly educated and privileged. It can so easily knock other forms of knowledge out of the arena. And it does this by engaging in a kind of linguistic obscurantism. We don't know what we're looking at always or necessarily, but given its technical detail, we assume that it must be correct. However, what we must always strive for is the integration of data and stories. Even when what happens sometimes is that they're attached, but with an almost invisible umbilical cord, so that we have to sense the story. In 21st century medicine, data is revered because it is used to tie diseases to their genetic triggers. But in order to ensure accuracy, it also must be tied to its story. In these cases, we're not referring necessarily to communities and neighborhoods and their experiential knowledge, but in reality, this issue of community and story is interwoven because it's about the reality of people's lives. But instead, in genomic science and medicine, we must refer to a different kind of story, and one that describes a population's ancestral past. That kind of story is, of course, what we call history. But then the question might be, why? Why do we have to focus, or why should we focus on history? Let me begin by telling you a secret about the Human Genome Project. We all know that it was launched in 2003 with high expectations. But the world it opened up turned out to be truly mind-boggling in certain ways. For instance, in 2003, it was believed that in addition to the approximately 22,000 genes that we all carry as members of the human species, that there were also variations, tiny biochemical variations. In fact, 2 million had been counted. However, by the time we got to 2010, that number had increased to 10 million. But now we're in 2024, and it just so happens that the number of variations that have been counted in the human genome are 324 million. Now, here's the problem. It's been extraordinarily difficult for scientists to figure out what most of these variants do. Some are neutral, some trigger diseases, many others create adaptations that allow humans in different ecological environments to function and to survive. Now, these variants cannot be identified and tracked merely by identifying their biochemical compositions. And herein really lies the problem, because we can gather all kinds of data, but that's not really telling us what they're doing. There was an even bigger problem attached to this issue of all these variants, that also emanated from the knowledge coming from the Human Genome Project. And that was, it turns out that our human diseases are population specific. And here again, we're not talking about race. This is because the groups that share the same disease triggers will be highly specific and highly localized. The medical example that I would like to present today will hopefully alert us to a very particular and powerful way that data equity in the field of genomic and precision medicine can be lost. And this is because the institutional power of data, when its inaccuracies are not addressed, can choke off other ways of knowing. And this can happen with fatal consequences. Now, some of you may have heard of a medical condition that uniquely kills 19,000 African Americans every year. It is called APOL1 mediated kidney disease, also known as AMKD. It is a serious genetic kidney disease caused by mutations in the APOL1 gene. However, the reason it is limited to Blacks in the United States, that is because the disease triggering gene variants, they're called G1 and G2, are carried almost exclusively by African Americans as well as West Africans. The initiating disease in each of these disorders is salt-sensitive hypertension. From there, the pathology sort of spreads into various different directions, including focal segmental, I'm not good at this, glomerulosclerosis, lupus nephritis, membranous nephropathy, nephrotic syndrome, HIV-associated nephropathy, kidney failure. And of great importance is the last, which is preeclampsia, causing high rates of mortality in Black female childbirth situations. Now, the reality is that AMKD has been researched extensively, and it has accumulated an enormous database. There have been at least 80 articles in PubMed, and PubMed's database is all very specific scientific articles. And then in Google Scholar, there have been more than 5,500 articles. And Google Scholar is also academic articles, but it's a little bit more expansive in terms of various disciplines. So what has happened over the years is the development of a medical consensus in the US. And this medical consensus, it's hard, it's rigid, it's strong. And it says that APOL1, G1, and G2 variants function solely as a natural immunity against trypanosomiasis. Trypanosomiasis is African sleeping sickness. So you can just take a moment to glance at the number of articles referencing this fact. And actually, I didn't do a good job of putting it together, but the point being that every article focused on APOL1 attaches itself to trypanosomiasis, this being the function of G1 and G2. Now, actually, between 2001 and uh, today, there were three very independent-minded researchers who identified a different function for G1 and G2, and that was a sodium retention function. Now, if, for instance, we compare the two functions, we can see that one, okay, here are my two functions here. One relates to African sleeping sickness, trypanosomiasis. Okay. And the other one relates to sodium. But here's the deal. It just so happens that trypanosomiasis is not killing anyone in the United States. On the other hand, if we begin to think about and look at the complex interplay of health risks triggered by the APOL1 variants, we begin to see a deeper principle at work. The initiating disorder for all Blacks who later develop chronic kidney disease, or APOL1 or AMKD, is salt-sensitive hypertension caused by consuming more sodium than the body can metabolize. But what if the paradigm that's being used in medical science essentially says that whatever the nutritional standard is for people of Northern European ancestry, that is universal? Okay, so in this situation, we have what I would call plan A and plan B in terms of what are the therapeutic options given seeing these variants in one way as opposed to another way. So plan A, salt being the trigger. If that is the case, it's dietary. It would prevent the AMKD progression if, in fact, there was a focus on limiting sodium intake in certain populations. But then there's plan B, where G1 and G2 are strictly related to trypanosomiasis. In that case, there's no trigger, there's no cure at this point, and researchers have, in the last 15 years, expended at least $100 million in research funding looking for a cure to this disease. So, why then would the medical community ignore the most obvious clues for preventing APOL1 in African Americans? Namely, the fact of the need for dietary sodium reduction. And one of the answers to that question goes back to the spring of 1986. We might begin to grasp the series of miscalculations brought on by our nation's ongoing attachment to seeing humans as belonging to races, this racial classification, and presuming that each race shares particular traits or genotypes. A professor of medicine named Thomas Wilson, who taught at the historically Black Charles Drew University, published what at the time appeared to be an intriguing article in Lancet. It was entitled History of Salt Supplies in West Africa and Blood Pressures Today. He asserted, and I quote, historical evidence concerning salt supplies in West Africa suggest that availability was not uniform. Reports that blood pressures in Senegalese and Gambians are lower than those in Nigerians may be a reflection of historical differences in salt supply. The difference in blood pressure between members of a racial group also casts serious doubt on the concept of racial homogeneity, often accepted in the medical sciences. And that's also referred to as racial essentialism. Each group has its own set of gene variants. That same year, in an effort to repudiate the accepted medical paradigm that all West Africans share the same racial genotypes, Wilson penned a second, even more unequivocal article. It reminded readers that Blacks with hypertension were suffering kidney disease at up to 18 times the rate of whites, with no cure in sight, and the particular form of hypertension was salt sensitive. He pointed to a simple dietary adjustment, namely that Blacks needed to reduce their sodium intake below accepted mainstream norms. However, a noted historian, Professor Philip Curtin, who hailed from the more distinguished Northwestern University, publicly ridiculed Wilson's work, even though the Northwestern professor's expertise was limited to examining the diaries of slave ship captains and their bills of lading. He dismissed Wilson's thesis as being sloppy and being inexact in terms of the citations and lacking in proper data sets. Curtin claimed, although it was an error, that in the 18th century, 80% to 90% of all slaves shipped to the New World originated within 100 miles of the coast. He then went on to say that there was no salt-poor interior of West Africa. Wilson's claim had been, of course, that slaves came from the sodium-deficient region, and they were genetically adapted to an environment that would not otherwise be survivable for humans adapted to higher sodium levels. In short, he was making what was essentially a genetic argument, but this was 2 decades before genetics had become an accepted part of medical science. However, seemingly overnight, the medical community de-sanctified Wilson's argument, identifying salt as a disease trigger for hypertension and kidney disease in Blacks. It only took one credentialed member of the establishment using data from slave ship records to end the discussion. This is the case, even though those records had really nothing to do with the ecological conditions of kidnapped West Africans from the interior in terms of what they were genetically adapted to. Several years later, Wilson's colleague, Clarence Grimm, proffered a new theory, and he did so because no one in the medical community was accepting this salt deficient interior hypothesis. So he felt that, well, maybe during middle passage, those whose kidneys retained more salt were those who survived. Now, this was batted around for a few years, even by Oprah Winfrey. But that theory eventually lost favor because there was really no evidence. So by the turn of our century, it had slipped into, this whole hypothesis had slipped into a kind of cesspool of so-called urban legends. It was just considered ridiculous. But why am I so certain that Thomas Wilson was right all along? Firstly, geological maps show that the interior of West Africa is sodium deficient. It has no halite, that rock salt that is mined. But there's even more to the story because people can look and see, oh, but there's the coast and there's plenty of salt in the Atlantic Ocean. But what's missing from that understanding is the fact that because of the tropical heat, sea salt could not be transported and sold within the deep interior. The deep interior, 500 to 1,000 miles beyond the coast. And this is because the heat would cause it to become rancid. And particularly because there would be impurities such as seaweed sort of mixed into the evaporation, the evaporated salt and so forth. So the point was that it smelled bad and it was not sellable beyond the coastal regions. Now, secondly, there were 3 genetic analyses conducted over the course of the last 20 years, in which, excuse me, G1 and G2 variants were seen as having a sodium function. We had in 2001 doctors Emma Baker and Nicola Ireson in London at St. George's Medical School in London. They found that, and I quote, generalized upregulation of sodium channel activity may account for the high prevalence of salt-sensitive hypertension. Okay. And then in 2013, there were 2 professors at Indiana School of Medicine who, in looking at these variants, made the following comment. The characteristic low renin salt-sensitive hypertension of Blacks is consistent with the kidney reabsorbing additional sodium, which leads to an expanded plasma volume that drives the blood pressure, that drives their blood pressure up. So here again, it's salt-sensitive hypertension. And just this year, there was an article by Professor Data and Professor Antonio from Duke University School of Medicine. And they were actually very, very specific. APOL1 mediated sodium potassium transport functions as the proximal driver of APOL1 mediated kidney disease. However, these articles had no visibility. I mean, fortunately, they were published, but they had no visibility. And the reason was because it didn't necessarily make much sense in terms of what does sodium have to do with this whole issue when we know trypanosomiasis is the actual function of these particular gene variants. Well, the issue might also be somewhat related to the fact that a rather lucrative industry had evolved, searching for the so-called cure to AMKD, in which millions of dollars were already being invested in this enterprise. And even though it appeared to be going nowhere, as long as there was research being conducted and data of some sort being generated, it would just go on and on. But there is another reason that I am absolutely certain Professor Wilson was right. And so I will just say something about my story. My academic career as an African evolutionary historian did not begin tracking rare gene variants to their ancestral ecological environments, and therefore identifying their biological function. This came much later. Rather, a youthful passion for studying the primary sources of history led me as an undergraduate to major in classical Arabic. It was the prerequisite for translating medieval manuscripts from Timbuktu and the late West African empires of ancient Ghana, Mali, and Songhai. These empires within the West African interior grew rich from profits made in the remarkably lopsided bartering of rock salt for gold. And the latter was being mined by decentralized populations outside the imperial boundaries. Now, this commercial arrangement attested to the fact that the interior of West Africa represented one of the most sodium deficient regions on the continent. And it was for this reason that these populations were willing to sell their gold for salt pound for pound, but it was rock salt coming from the Sahara. It wasn't, as I said, coastal salt, which was not sellable. But what seized my imagination even more were the events that occurred when the gold from these fields eventually ran out. Beginning in the 17th century, slave raiders descended onto these unprotected villages in the interior and marched these newly enslaved peasant farmers 500 to 1,000 miles in chains to the coast. Uploaded onto slave ships bound for the Americas, these men, women, and children were my ancestors and the ancestors of 37 million other African Americans of slave descent. Given that historical event, African Americans now consume 6.8 times more sodium than their West African ancestors. So let me just say in conclusion, 19,000 African Americans will die this year from a preventable disease that the victims know nothing about. They have been told nothing about its ancestral history. They've been told nothing about how it might be prevented in the first place. The ancestors of Black Americans consume less than 500 milligrams of sodium per day. African Americans are admixed between West Africans and Northern Europeans. So most Black Americans should probably be consuming salt within the range of, say, 1,500 milligrams a day, even though the USDA recommendation is 2,300 for the American public. And most Americans, including African Americans, everybody, consumes 3,400 to 5,000 milligrams a day. Now, West Africans living on the coast, because they have the advantage of sea salt, are likewise adapted to similar sodium levels as Americans. And after all, they are not the populations with G1 and G2. Consider for a moment the biological trauma of any human population transported to an environment where they were compelled to consume what for an American eating 3,400 milligrams of sodium would turn out to be 23,000 milligrams of sodium. That is 6.8 times our intake. The renal pathologies created would be no different from what we now know as APOL1 mediated diseases. In short, the data was unable to help us control this disease because the medical consensus left out the historical story. When data is valued, but the story that attaches to it is not taken seriously, something odd happens. Researchers will just keep doing what they know how to do best, which is more and more research until the funding eventually runs out. And in that case, the same number of human lives that were lost 20 years ago from AMKD will be lost this year and next. Data without its story cannot lead us to truth. Thank you.
Thank you so much, Dr. Hilliard. I'm blown away. The depth of your story, the intelligence of your story, and the way that you tell your story are fundamentally changing to how we all think and are trying to learn to rethink research. And this was an incredible presentation, and the value will be many, many years.
Thank you.
Yeah. And I want to reemphasize to everyone here that this is a very special event. Dr. Hilliard does not do a lot of talks. And so we're really, really grateful that you were willing to make some space. And yeah, I'm not even sure I can even really talk now. I think, okay, so yes, you can see there's so much gratitude and thanks in the chat. And that's not just for the talk, but for all of the work that you've done and the bravery it takes. It takes a lot of bravery, especially when you're like in the formal academic situation that you're in, to stand up and say, hey, you other fancy academic, here are all the reasons that I think you're not right. So what I want to do now is open it up. There's a few questions in the chat, but if you're in the room and you'd like to turn your microphone on and ask a question, this is your chance to do that now. So you could raise your hand using kind of the Zoom hand raising function, which is under the heart that says reactions in most versions of Zoom. Or you can just turn your microphone on if you can't find that, because there's enough people here. Yeah, somebody's saying this is research at its best, and I absolutely agree.
Thanks.
This
Thank
is
you.
research at its best. So is there anybody in the room that wants to ask a question? Or I will take one of the questions in the chat is one of the questions in the chat is, let's see, there's a couple. What could our role be in promoting your research and this insight? That's a really good question.
Oh my goodness. Oh, that's wonderful. You know what? I think for those of you who have really absorbed my points, it's just a matter of reflection on what your particular work is and the ways in which your particular work might intersect just some aspect of what I've talked about. So I really can't be specific for everyone, but I think that it really takes some reflection. And when I say that, I have to kind of laugh because in talking with Heather, I had mentioned the fact that when I first heard from her, and she sent me an email and she mentioned data equity, and I'm thinking, data? I'm a historian, I don't do data. And then as I reflected on it, I realized, well, of course I do data. But my point being that we can all take some time to just think about some of the issues, and that's when we begin to see the connections that might be made in some way. And I think in a very general point, just in terms of any work that is being done that relates to data and human beings, but it just so happens particularly relating to kind of contemporary medical issues and genomics and so forth. We just have to demand the story. We have to assume that there is a story worth telling, and there is. And when I think about that, to me, it's almost like when you're working in this area of data equity and you're demanding to hear from the community, that's what I mean by story. But it just so happens that when we're dealing with medical genomics, the story, the reason the story is historical is because it's about what a particular population's gene variants have become adapted to in order to allow for survivability in a particular region. And oftentimes it's relating to some populations have disease immunities and so forth. And, some populations live at the top of the Himalayas, or uh, these indigenous people in the Atacama Desert of Chile, and it's arsenic filled or whatever, that
Yeah,
sort of thing.
that's such a good example. So, Dr. Hilliard, there's so much happening so quickly right now in genomics. And we have the opportunity sometimes to work with people who are in genomics. And just from like my own personal relationships with them, so many of them are under the very same kind of financial and time pressures that you were talking about.
Yeah.
I was so excited to read you thinking about in terms of this is creating falsehood in a really important, like, this is, if genomics are going to really drive precision medicine, like the title of your book, what it's like to be an African American in this new thing, precision medicine. I have so many questions, but are you feeling hopeful that genomics and precision medicine are gonna kind of break through some of the racial stereotyping and racial essentialism that is so prevalent in medicine right now? Or are you really worried that used incorrectly, genomics is going to be another layer of doubling down?
Yeah. Well, I wish I had a clear, simple answer, and I don't. I mean, some days I'm hopeful and some days I'm ready to give up. But I think that one of the problems is that the genomics community has
Mhm.
not yet faced
Yeah.
the reality. And see, the reality isn't, there are different realities. The reality isn't just, say, racialized medicine or
Mhm.
people getting back into eugenics or something.
Yeah.
The problem that we haven't faced is the 324 million gene variants, because one of the issues that I'm amazed at how obscured it is the fact that most of these variants are still in the on the African continent.
Mhm.
And
Mhm.
that becomes one of the issues. But another issue, and I hesitate because it'll sound a little conspiratorial, I guess. But now listen,
Yeah.
what happens is that um, we have to forget what race and we have to focus on stratification. And what
Mhm.
I mean by stratification is that now that we know that so many diseases are population specific, it so happens that precision medicine has made some very remarkable breakthroughs for people of Northern European ancestry. But the reason it's so limited is not because they haven't tried to bring in a few people here and there to sort of show diversity. It's because of the fact that population specific disease triggers means that you may have a particular type of cancer. Other people of Northern European ancestry will have the same disease variant. But if they're from Eastern Europe or from Africa or from some other place, they won't. So what happens is that I don't think it's a conscious thing, but the more homogeneous the genome is that is being studied, the more valuable it will be for that population because it will connect the diseases to what is triggering them. But that brings me to another point, and that is all of us know what diversity means, and it's very meaningful to me. I mean, you want to have many, people from different ancestral backgrounds having opportunities. This is what America is supposed to be about. That is diversity, but we can call it racial, cultural diversity. But human genetic diversity is something totally different. Human genetic diversity is the number of gene variants in a particular population. And the reason Africans have the most gene variants is because they are our ancestral population. Well, what that means is that when when geneticists and medical researchers are not stratifying populations, what will happen is that the only people who will get linked to have their disease linked to a particular variant will be those that are most in the range, in this homogeneous range. So what ends up happening is that we talk a lot about diversity, but when you really get down to the genetics of it, we have to learn how to differentiate populations having nothing to do with race, but differentiating them in terms of what populations share the same disease triggering gene variants.
Mhm.
And that is something we haven't been doing. We've been almost pretending by saying, oh, yeah, we're going to have this genome and it's going to have everybody. Well, the genome with everybody is going to help nobody except whichever group is the most homogeneous to begin with. I mean, whichever gene variants came from the same group. So what happens is it's like we're not ready to announce what we're dealing with.
Yeah.
And I
Mhm.
I began to really think about it when I was reading some article from some Chinese researchers, and they were essentially explaining how the Chinese genome was stratified into the Northern Han, the Southern Han, and the Beijing Han. Now, why were they doing that? They were doing that because each one of them had the same disease triggering gene variants, more or less. And the maybe the last point I want to make here is that sometimes in America, we can be a little bit too arrogant and think, oh, well, because we're American and we have all this money and whatever, that we're just going to put it all together. But the reality is that we need to use diplomacy, because if we want to really help Americans, because we have this beautiful admixed population and we have the capacity to know what our ancestral DNA is and the admixtures, we need to connect with every country that has um, genetic databases, because even I'm talking about, I keep talking about Northern Europeans, but the reality is that if you want to cure more white people, you need to connect with the English databases, the Scottish databases, the Irish ones, the German ones, the Polish ones, and so forth, because they're stratified just because most nations are tribalistic. They're
Right.
stratified. And it is the same situation for Asians and Africans and so forth and so on. Rather than pretending that we can somehow figure it all out, which we can. Well, I mean, we can't even figure out the G1 and the G2. What we need to do is to be able to reach out to other nations, because their databases are almost by definition more stratified than ours.
Such a good point. Such a good point. And figure out a way to connect with those nations in a way that isn't colonial and
Yeah,
extractive.
yeah, exactly. Or dropping bombs on them or something.
Or violent. Yeah. I
Yeah, or
mean, it's
violent.
not funny. It's very
No, it's
real,
not.
right?
No, no.
I mean, yeah. So that's a great point. And I really think we're gonna leave it there
Okay.
because we're at time. And I think you've blown everyone's mind. This has been such a valuable hour, and I know how important an hour is in your life. And I really want to emphasize how grateful I am personally, and we as a group are, that you were willing to talk with us for an hour. I mean, I don't think there's very many other people I know that in the middle of an already mind-blowing speech just kind of casually mention, oh yeah, the first thing I did was learn to read and write Arabic.
Well, thank you,
Um,
thank you, thank you.
and so thank you so much. And for everyone who's asking about the recording, because I know we're all going to watch the recording again to continue to kind of wrap our minds around it, think how we can apply it to our own work, both personally and professionally. The link to this recording, along with lots of resources. We've also had people suggesting resources in the chat. We'll put all those resources into that forum. Dr. Hilliard's book is called Ancestral Genomics, African American Health in the Age of Precision Medicine, just recently published. It blew my mind. And so I highly, highly recommend it if you are looking for some amazing reading material, because you have just seen a small glimpse of Dr. Hilliard's brilliance here. All right, great. Happy to hear you just bought the book. Thumbs up. All right. So we're gonna leave it there. Have a really good weekend. Take really good care of yourselves and those around you. And we are back next week. The Zoom link never changes, it always stays the same. So I will see you all next Friday. And thanks again, Dr. Hilliard. Really
And thank
appreciate
you
it.
so much. I really appreciated it. Bye-bye.
Okay, bye everybody.